right, we are starting section 1.3 today, which is continuity and behavior and limits. So the goal for today is I can use limits to describe end behavior of functions. You've done this before, but you just haven't used limits to do it. You've described end behavior before, that is, but you just haven't used limits to do it before. So here's the warm-up. Find the domain, y-intercept, and x-intercepts for each function. Go ahead and pause the video and try these two on your own, and then come back and check answers with me. Okay, so let's start with domain. First thing I ask myself are there any restrictions? Yes, there are, because there is a denominator. Denominators cannot be 0. So x plus 1 can't be 0, and therefore x cannot be negative 1. So my domain is negative infinity to negative 1 union negative 1 to infinity. All right, next, my y-intercept. I find y-intercepts by plugging in 0 for x. So that's what I'm going to do here. I'm going to plug in 0 in the numerator. That gives me 0. Plug in 0 in the denominator. That gives me 1, which simplifies to 0. So my y-intercept is 0, 0. When I plugged in 0 for x, I got 0 for y. Last, my x-intercept, I get by setting y equal to 0 and solve. So I have 0 equals 2x over x plus 1. Remember, this equation right here is a fraction set equal to a number. Whenever you have a fraction set equal to a number, the easiest way to solve it is to make the number a fraction by putting it over 1 and cross multiplying. So that's 2x equals 0, divide by 2, x equals 0. So my x-intercept is 0, 0. And it should make sense that if the y-intercept is 0, 0, the x-intercept is 0, 0. They go hand in hand. All right, next one right here. I want to know the domain. Ask myself, are there any restrictions? No, there are not. There are no square roots and no denominators, so my domain's all real numbers. Next, I need to find my y-intercept. So that is by plugging in 0 for x. 0 cubed minus 4 times 0 is 0. So my y-intercept is 0, 0. And finally, my x-intercept, set your function equal to 0 and solve. All right, here, remember when you have exponents, the first thing you have to ask yourself is, can I solve it by factoring? In order to do that, it has to be equal to 0, which it is. And now I'm going to look for a GCF, and there is one. There's a GCF of x. And now I can set each factor equal to 0 and solve. So I have 3 x-intercepts here. I plugged in 0 for y and I got 0 for x, so 0, 0. I plugged in 0 for y, I got 2 for x, so 2, 0. And then I also got negative 2 for x, so negative 2, 0. If you want to write this as plus or minus 2 comma 0, that's fine also. Okay, so new material. We are talking about limits today. So limits is a calculus topic. Okay, so that's the concept of approaching a value without necessarily reaching it. So here's how I have students think about it. It's really hard for me to explain this without you seeing me, without you seeing my hands, but I'm going to try my best. So limit is a y value that a function approaches but doesn't necessarily reach it. So what you have to remember about not necessarily reaching it, it's what it intends on reaching. So if I say I intend on going grocery shopping tomorrow, that doesn't mean I'm going grocery shopping tomorrow. It means I'm headed in that direction. It's the direction I'm going, but I'm not necessarily going to make it there. Okay, that's what a limit is. So that's what it says here in layman's or in actual math terms. I just said it in layman's terms. So I actually like doing example 1. Talking about this first. We're going to talk about end behavior, and then we're going to actually talk about the limits itself. So we're going to talk about end behavior and writing it in limit notation. So when you guys were in Algebra 2, you learned end behavior, like what do the ends of the graph look like, okay? So how you set it in Algebra 2 was as your x values approach negative infinity. So as you're looking to the left on your graph, this is saying what's happening to the y values. So as you go towards the left on your graph, you can see that there's an arrow pointing up, which means that your y values are approaching positive infinity. This says as your x values approach infinity. So as you're looking right on your graph paper, what's happening to your y values? So if you look, as you go from the left to the right, your y values are going down. So that means your y value is approaching negative infinity. So that's how you guys wrote it in Algebra 2 with trig. This is how we write it in pre-calculus and calculus. We say the limit as x approaches negative infinity, and then whatever the function name goes right here, so of f of x equals, and then so you're going to look over here, it's as it goes to the left, it's going upwards, so towards infinity, and then the limit as x approaches positive infinity of the function. So this is saying as your x values are getting bigger, or as if you're looking to the right, it's going downward, so negative infinity. That is limit notation. Okay, and that is end behavior. So if you look, we next discuss one-sided limits and then finding the limits basically anywhere in a graph. We end this with, given the graph of f of x, find each end behavior using limit notation. So I'd actually like to move to example 4 right away because I just explained what it is, okay? So you got to really get into the practice of writing it correctly. This says, given the graph of f of x, find each end behavior using limit notation. So you are writing in limit notation. All right, so you're going to write the limit as x approaches negative infinity, and then whatever the function's name. It says that all of these are going to be called f of x. So of f of x equals, so you're going to say as you look left on your graph, as your x values are getting smaller, what's happening to your y values? They're going up higher, so that's infinity. Then we have to do the other side. So the limit as x approaches positive infinity of the function is equal to, so as your x values are getting bigger and bigger, if you look at your y values, they're getting smaller, so they're approaching negative infinity, and that's your end behavior. All right, let's look at this next one here. We're going to start with the limit as x approaches negative infinity. The limit as x approaches negative infinity of my function f of x is equal to, so here I say, okay, I'm going to watch my x values get smaller, watch my x values get smaller and smaller. So as I'm looking left on my graph, my arrow is not pointing up, my arrow is not pointing down, it's approaching a y value. So I'm going to say what y value it is approaching. If you look right here, it is approaching the y value of 2. Ooh, that does not look like a 2 though, huh? Eraser. Of course that dies. Let's try opening it up again. I'm not starting over. I refuse to. Oh no, that's not helpful. Where are you? There you are. I refuse to start over. Sorry, guys. Let's go down here. Okay, so as you look left, we said it's approaching 2, so I'm going to put a 2 right here. All right. Now I'm going to do the right-handed limit, the end behavior on the right side. The limit as x approaches positive infinity. So as my x values are getting bigger and bigger, I'm going to look on my graph and I look to the right, and my y values, that's an arrow pointing upwards, so they're approaching infinity. Go ahead and pause the video and try C and D here, and then compare your answers with mine. All right. Limit as x approaches negative infinity of the function f of x is equal to negative infinity. The limit as x approaches positive infinity of the function f of x is equal to negative infinity. The limit as x approaches negative infinity of the function f of x is equal to, this is leveling off right here at negative 3. The limit as x approaches positive infinity of the function f of x is equal to, leveling off also at negative 3. Okay? So your end behavior can either be negative infinity, positive infinity, or a number if it's leveling off. So you just have to look at the graph and be able to decide which one. Okay, so that's just the ends. Notice that's the limit as x approaches negative infinity or positive infinity always. Okay? But what happens when I bring up these types of problems? The limit as x approaches 1, or the limit as x approaches 3, or 5, or negative 4. How do we do that? So in order to see how to do that, we are going to first talk about one-sided limits. In order to calculate a limit at a point, we have to consider the left-sided limit and the right-sided limits, which we can do by looking at the function from the left or from the right side as we approach some x value. We can use the following notation for one-sided limits. So this is what a one-sided limit looks like. It's the limit as x approaches, and then this will be a number, and then there's a little minus sign raised up as a superscript to the right of that number. That means from the left. So this means from the left. And then if you look at a right-handed limit as x approaches, and then this would be a number, and then there'd be a plus sign as a superscript, and that means from the right. This little plus sign does right here. Okay? All right, so if you find the left-handed limit and the right-handed limit and they're the same value, then that is the limit. If they're two different values, then the limit does not exist. Okay? If one-sided limits are different, the limit does not exist. So we teach you one-sided limits so you understand how to find the limits. Okay, so we're going to start with A here. Let's make sure we know how to read it first. This says the limit as x approaches 3 from the left of the function f of x. So the limit as x approaches 3. So we are going to find the x value of 3. The x value of 3 is, I'm going to put a dashed line here on my graph so everyone can agree that that's where 3 is. It's right here. Okay. So what we're going to do is we are going to approach the x value of 3 from the left. So if I'm on my graph and I start getting closer and closer to the x value of 3, I would start this way. And I come up here, and then it picks back up here, and then it comes back over here. And then all of a sudden I'm getting closer and closer and closer to 3. So I want to know what y value I'm getting closer and closer to. So really everything before this didn't matter. I want to know from the left what y value I'm approaching, and that is negative 4. Now I'm going to do the same thing. I'm going to approach that value from the right. So I'm going to come from the right, and you can see that you're approaching negative 4. So since you're approaching the same value from the left and the right, that is the limit. So the limit as x approaches 3 is negative 4. Our whole goal is for you to be able to get to this. So you might have to ask yourself this question and this question to get this answer. All right, let's do B next. Limit as x approaches 5 from the left. Okay, so I'm going to erase everything that I have on here, including this. Okay, so 5. Here's 5 right here. Okay, so I'm going to approach 5 from the left. So here I come, I'm approaching 5 from the left. What value am I approaching? I am approaching the value of negative 2. So you might be saying right now, there's a hole there, there's no value. I said approaching. What value am I getting closer and closer to? It's not what value did I reach. Remember, by the definition, it's approaches. All right, now I'm going to approach 5 from the right. So I'm coming from the right. If you look right here, you are also approaching negative 2. So the limit, oops, I'm writing it in the wrong spot. So in case you were like, what just happened? Here it is. 5 from the left was negative 2. From the right was negative 2. So the limit as x approaches 5 is negative 2. Okay, let's do C. I hate how it's A and then B's below it, but whatever. All right, so C, the limit as x approaches 1 from the left. So once again, I'm going to put a dashed line where 1 is, just so you guys can see where it is to see what I'm talking about. Okay, so there's the x value of 1. All right, I'm going to approach the x value of 1 from the left. So here I go. I approach it, and I look at what y value I'm approaching, and that is positive 1 right here. Okay. All right, now I'm going to approach 1 from the right. So here I am approaching the x value of 1 from the right. I'm going to say what y value I'm approaching. I'm approaching negative 2. So if you look here, I'm approaching 2 different values. So here the limit does not exist. The limit does not exist. All right, last one. Let me erase all this once again in this section here. I have the limit as x approaches negative 4 from the left. So I don't have to put a dash line at negative 4 just so you guys can see what I'm talking about because there already is one. All right, I'm going to approach negative 4 from the left. So here I come, I'm getting closer and closer to negative 4. And if I asked you what y value am I approaching, you can see that it's an arrow pointing upward. So it's going on forever and ever. So I'm approaching, air quote, infinity. All right, now I'm going to approach the x value of negative 4 from the right. And I see that once again it's an arrow pointing upward. So that's positive infinity. So if I asked you, what's the limit? These two are the same, so the limit is infinity. Now, technically, if you were in calculus, they would not say that this is the answer. They would accept it 100%, but you could also say that the limit does not exist here because by definition, the limit is the y value the function approaches. So infinity is not a number. It's not a y value. So we could say it does not exist. So either one of these is fine. So please keep in mind this. Left-hand limits can be infinity. Right-hand limits can be infinity. Limits themselves can be infinity, but that means it does not exist. Okay? Now, don't confuse that with end behavior. End behavior always exists. There's something always happening on your ends. Okay. Why don't you pause the video and try these on your own and see how you do, and then come back and compare your answers with me. Okay, so I'm going to start with asking the question of 2 of these are asking about end behavior, the other 3 are not. Which 2 are asking about end behavior? This is asking about end behavior, and this is asking about end behavior. Right? The limit as x approaches negative infinity. The limit as x approaches positive infinity. So these are end behavior. All right, so let's do the end behavior ones first. The first one says the limit as x approaches negative infinity. So as my x value is getting smaller, what's happening to my y values? They're pointing downwards, so they're getting smaller also, so negative infinity. The last one, e, the limit as x approaches positive infinity. As I look as far right as my graph goes right here, there's an arrow. It's not pointing up. It's not pointing down. It's leveling off at this y value, which is negative 1. So my end behavior there is negative 1. Okay, now let's do the other limits. So this one says, no, letter B says the limit as x approaches negative 1. So once again, me putting a dashed line here is just to help you. If I was in class, I wouldn't be doing it because I'd be pointing to where negative 1 was. All right, so there's negative 1. So what I'm going to do is I'm going to approach negative 1 from the left and say what y value I'm approaching. Okay, that looks like about 2.5. Now I'm going to approach negative 1 from the right. I'm going to say what y value am I approaching, and that looks to be about 2.5. So the limit does exist since it's approaching the same y value from the left and the right. And that is about 2.5. I wish it was 2. It's just that we tried really hard to make the graph nice. And it's just, it moved. It moved. It really did. It was at 2 last year, I swear. Okay, next one. Let me get rid of this. All right. And if you look at my answer key, my hard copy of it, like you can see that the graph must have moved a little bit when I was making it into a PDF. No big deal, though. All right, the limit as x approaches positive 1. So now I'm going to go to the x value of positive 1. All right, so I'm going to approach positive 1 from the left and ask myself what y value I'm approaching. I'm approaching the y value of, this is 1. All right, now I'm going to approach x equals 1 from the right. So here I am approaching it from the right. I'm going to say what y value am I approaching, and that's negative 2. That is 2 different y values, so here the limit does not exist. All right, last but not least, Limit as x approaches 3, so 3 is right here. Approach 3 from the left. What y value am I approaching? -3. Approach 3 from the right. What y value am I approaching? -3. So the limit does exist, and it is -3. Okay, so things that I want you to notice before we do the last part, which is the domain, is the limit did not exist here, okay? If you look at what's on the graph there at 1, this right here, from this point to this non-point right here, this is called a jump. That's in tomorrow's notes, but there's a jump in the graph. It jumps vertically. So limits are not going to exist at jumps. If you notice right here, this is not called a jump. This is called a hole. If you look at the hole, which is at x equals 3, the limit does exist there. So limits exist at holes. Limits don't exist at jumps. Okay, last, what is the domain of the graph? So your domain is all possible x values. So I'm going to start on the left, and it's an arrow pointing to the left, so that's -infinity into my negative values. And it keeps going, it keeps going. And then this piece right here stops, but notice it picks up vertically and keeps going. So I don't want to say that my x values stop at 1 because there is an x value at 1. And if I'm stopping there, that means that there is no x value at 1. So I'm going to keep going, and it stops at 3. And there are no x values. If you look, there's no x values at 3. So I'm going to stop my graph there and say 3 is not included. Union picks back up at 3 and goes forever. So there's my domain. All right, the very last part is sketch a graph of a function that has the following end behavior. Okay, so I want to sketch a function that has the end behavior. So this says that the limit as x approaches -infinity of the function is infinity. So that means on the left-hand side of the graph, I should have an arrow pointing upward. If you look here, the limit as x approaches positive infinity is 3. So as you're looking right on your graph, your function needs to approach 3. So here's 3 right, well, I shouldn't say right here because you can't see it. So I'm going to put an arrow that's leveling off at 3. So now I can connect these two, and now I have a graph that has those qualities. This one here, the limit as x approaches -infinity is -infinity, so I want a downward facing arrow. The limit as x approaches positive infinity is also -infinity, so another downward facing arrow. So now I just have to connect these two arrows with any sort of graph that I want. I could have a parabola, I could have something that has an extra bump in it, but that would be a graph that has those qualities. All right, that's it for 1.3 Day 1 notes. If you have any questions on limits as you're working on the homework, please pause the video and ask.